right, welcome back. So we're finishing up the graphing section. That's section 6.6 in your book, and we're working through the activities. So I left off, number 4 is next on your activities on the last two sheets. All right, now on this one, it's not already solved for y. So you might question, should I point plot? Should I y-intercept? Should I solve for y? It's up to you. I'm going to demonstrate both ways. I guess there's all three ways. The first way is just general, pick any point that you like. A lot of times students do 0, 1, and 2. Again, remember, you only have to have 2 real good points, but it's good to have a third to check yourself on. So point plotting, I would say 2 times 0 plus what equals 3. Equation solve that zeroes that out and just says y is 3. So that's a point I can plot. Then do 1 for x, 2 times 1 plus what for y equals 3. 2 plus y equals 3. Throw the 2 across the line. Y equals 1. Now, if you're real confident you haven't made a mistake, just take those 2 and go with it. But I always recommend, the book always recommends you have a third point to check your line. So 2 times 2 plus y equals 3. That's 4 plus y equals 3. Move the 4 across the line. Y is negative 1. And there's no magic of 3. You could keep plotting. You could do this the rest of your life. We said there's infinite solutions that solves this equation. But 3 is just kind of the minimum one should do if they're going to do point plotting. So then we'll plot those 3 values. Now if you're doing it on the computer, it only lets you plot 2 actually. Once you plot the second point, it just draws it in. But you can kind of eyeball it and see if the third one falls on it. But 0, 3 would be right here. 1, 1, 2, negative 1. And you feel good about that. They seem to line up, so I feel like I haven't made a little mistake with my negative sign or something. So that's one method to graph. The second method we talk about is the intercept method, where you specifically got to do the 0, 0. So 0 for x is already done. I picked that one, plugged in 0 for x. Now I'm going to plug in 0 for y and see what x is, and then I'll have, oops, I forgot to change it to 0. So that's 2x equals 3, divided by 2, x is 3 over 2. That's my x-intercept. Now the computer has a little trouble with fractions sometimes. Again, it's not calibrated for that. So any that you have on your math program will probably come out even because of that. But just for this example, we have that point 0, 3. Then 3 over 2 would be 1.5. So over 1.5 is 0. And it kind of looks like I didn't get that in there just graphed perfectly, but it's in the ballpark. 1.5 is 0. And then I would just graph from those 2 points. And I would be graphing with only my 2 intercepts, my y-intercept and my x-intercept. Now, the third method, which is my favorite, is the slope-intercept method. And it has to be solved for y, so this one is not. The first 3 examples we did were already solved for y. Here I'm going to have to move the x term across the line, so it'll be just y, positive 1y, equals negative 2x thrown inside that, and then bring down the positive 3. And then that one's solved for y now, so I use slope-intercept method. So this is the start here at 3 on the y-axis. Then this is your rise over run. It's not over anything, so put that over 1. So that means rise negative 2, so that's down 2, run positive 1. And see how that works. That draws in the line that way as well. So again, solving for y. If there's nothing in front of the y, we won't have to divide out. But this one was already pretty good. That threw that across the line. Then bring down your positive 3. That's your start here number on your y-axis. And then rise over run from that point. All right, let's try that again. Number 5. Now, number 5 is going to be a little tougher to do with really any of the methods. It's just a tougher example, more coefficients and the negatives and such. But I do want to demonstrate how it would look with the slope-intercept method. To solve it for y, you always throw the x term to the opposite side, which will change this to the opposite sign. Bring this down, negative 3y equals, that becomes positive 2x. Bring down that to positive 12. Now on this one, I need to divide by negative 3, right? Because I have to have just y equals. I can't have negative 3 there. So I have to divide out the negative -3 to all of it, all the terms. That cancels that out. And then we've got really two problems. This is over -3, and that's over -3. So this first fraction will be -2/3. You know, it's negative because of positive over negative, and the negative can be on top or bottom. That's your call. Sometimes you just see it on the outside. And that has our x term. And then the 12 divided by -3 comes out even to be -4. Now it's in slope-intercept form, and I can use my method. That's the start here method. That's your y-intercept. So 1, 2, 3, 4, -4. And then from there, this is your rise over run. I'm going to use my negative with the top. -2/3. From there is down 2, and then right 3. And then connect your dots. Note that you could have used the negative on the bottom. This is the same thing as 2 over -3. -2/3, 2 over -3, same idea. The negative can be top or bottom. So then I would have said at -4, I'm going to rise +2, so up 2, and then run back 3, -3, 1, 2, 3. And notice it falls on the line the same. So either way, it works out. All right, number 6. Number 6, we have an x plus y equals 3. And I'm going to demonstrate that with the various methods. If you did point plotting, back to point plotting, and did 0, 1, and 2, you could plug in for the x value, like 0 plus what is 3. This is one you probably could go back to where you started here and just think of numbers, two numbers that add to be 3. You know, 0 and 3, 1 and 2, and 2 and 1. You could probably just think those up. But our method still works. Plugging in 0 for x gives me y is 3, and then I'll just go ahead and say what those values are. So you could point plot. And you might just know numbers that add to be 3 without even any of this rigmarole, right? But then when you connect the solutions, notice they line up perfectly. You could also have used the slope-intercept method by solving for y. You would have thrown the x across the line and had positive y equals -x plus 3. This is your y-intercept, 3, and then -1/1 for your rise and run, so down 1/1 connects those dots, be exactly the same. Okay, now our special cases. So we're down to the end here, 7 and 8. 7 and 8 are the special cases where you only have one variable. So when it's y equals, on number 7, y equals is a horizontal line. And on number 8, when it's x equals, it's a vertical line. All right, so let's draw those in. You don't even have to think about these. It's just a memorized thing. Y equals 5, go 1, 2, 3, 4, 5. Since it's positive 5, go up on the y-axis to positive 5. Now on your computer, you're going to have to tell it another point over here, so you have to click either beside of it somewhere, so it'll draw it out flat for you, draw it out horizontally. You have to push 2 points for your computer to draw that in a line for you. So just click any 2 points on the horizontal line, horizontally on 5. And then the last one, number 8, vertical. We go to x is -3, so back 3 on the x-axis. Click there, and then anywhere above or below it to draw it out vertically. So the vertical line when x